Have you ever stared at a math problem and just felt like you were hitting a brick wall? A wall made of abstract concepts you just can't seem to picture in your head. Well, we're going to look at a story about a teacher in Indonesia who found a way to absolutely smash right through it. So why is some math just so hard to picture? For a lot of us, certain parts of math feel less like a concrete science and more like a bunch of invisible, kind of arbitrary rules you just have to memorize, right? We're going to dive into a specific case where this exact problem became the spark for some incredible innovation. All right, let's get into it. The setting is a high school math class in Indonesia, and the teacher was up against a classic challenge, one we're calling Math's Abstract Wall. Okay, so the topics on the table were function composition and inverse functions. Now, if you've been through higher level math, you know these can be a real headache. They're all about how functions interact with each other, but they're usually taught through memorization and just static examples on a whiteboard. There's no movement, no life. It's exactly like trying to figure out a dance by just looking at one single snapshot. And here's the result of that static teaching. Check this out. Only 55% of students were passing the tests that measured if they actually understood the concept. Yeah, sure, more of them could crunch the numbers and get an answer, but barely half the class really truly got the why behind it. That was the wall. So the teacher, seeing that 55% number, knew something had to change. But it wasn't enough to just know her students were struggling. She had to figure out exactly why. She really dug in to find the root of the problem. And she uncovered 4 huge obstacles. First, the big one, a lack of dynamic visuals, which meant students could never see how changing one thing affected another. Second, there were these really common misconceptions that were just clouding everything up. Third, the feedback loop was just painfully slow, so mistakes wouldn't get corrected for days. And finally, you had this huge range in student readiness, a real challenge in any classroom. In this slide, this is a perfect example of one of those big misconceptions, the inverse function. To the students, it was just algebra. You just flip the formula, right? But they were totally missing the elegance of it, the geometric truth that an inverse function is a perfect mirror image of the original, reflected across that y equals x line. They had the steps down, but they were missing the whole point. So with all this in mind, what did she do? She didn't just print out a new worksheet. No way. She engineered a full-on interactive breakthrough, something designed to just completely demolish that abstract wall. And this is it. She called it MEFI, the Interactive Function Exploration Module. This wasn't some off-the-shelf app, This was a custom-built set of tools she made herself using the dynamic math software GeoGebra. The whole point was to make these invisible math concepts something you could actually see and, well, play with. So, how did it work? Okay, for function composition, the first module, MEFI 1, lets students see 2 different functions right there on the screen. Then, and this is the cool part, they could use a simple slider to change a number in one function. And boom, they would instantly see the final composed function change in real time. It wasn't just a calculation anymore, it was a visible chain reaction. Now, for the inverse problem, MEFI 2 was honestly kind of genius. Students would still do the algebra on paper, the old-fashioned way, but then they'd plug their answer into the module. And if their graph popped up as a perfect mirror image of the original, they knew they nailed it. If it was lopsided or just wrong, they got instant visual proof that they needed to check their work. No waiting for the teacher to grade it. I mean, look at this. This was a total 180 in the classroom. We're going from rote memorization to actual deep understanding, from staring at static pictures to getting your hands dirty with dynamic exploration. And maybe most importantly, from that slow, I'll get your test back to you next week feedback to instant personalized aha moments right there on the screen. Okay, so this all sounds great, right? An innovative teacher, a cool tool. But here's the real question. Did it actually work? Did all this effort translate into better outcomes? Well, the data tells a pretty incredible story. Just look at this jump. Remember that 55% pass rate for conceptual mastery? The students who really got it? After using MEFI, that number skyrocketed from 55% all the way up to 83%. I mean, that's not just a small bump. That's a complete game changer. 83%. The teacher's original goal was to hit 80% mastery. So this intervention didn't just meet the goal, it blew right past it. That 83% represents student after student who went from being totally lost in abstract ideas to really confidently understanding the material. And the change wasn't just something you could see on a spreadsheet. You could feel it in the room. The entire vibe of the classroom shifted. Students weren't just sitting there passively, waiting for the answers. They became active explorers. They were playing with the sliders, talking to each other about what they found. They were into it. So as we start to wrap this up, it would be really easy to just say, wow, that software was the solution. But the true innovation here, the real lesson, it's about something way deeper than just a cool program. The real success came down to 3 key things. First, the tool bridged that massive gap between doing the algebraic steps and seeing the geometric concept. It connected the how with the why. Second, it let every student move at their own pace. And third, and this is so important, it made the teacher even better. These quick online quizzes gave her instant data so she knew exactly who needed help, right when they needed it. This whole story is just a fantastic blueprint for what happens when thoughtful teaching meets the right technology. It's proof that with the right approach, we can make even the most abstract, headache-inducing ideas visible, interactive, and honestly understandable. And that leaves all of us with a really exciting question to think about. What's the next abstract wall out there that we can break down?